Hello guys, how are you? Assalamu alaikum. We have question 36. It says study the opposite circuit and calculate the electromotive force and internal resistance for the battery. Okay, as you can see, I have electromotive force here and internal resistance small r. Okay, so here I have two variables. It means I need to write two equations, okay, and solve them simultaneously. Okay, so let's start when the switch K is open. So when K is open, I'll write here open. Okay, we will have notice this part doesn't exist since the K is open. So I have the external resistance is 5 ohm. So I have R capital, it is 5 ohm. And the current, notice here, open, I have the current 1.636 ampere. Okay? So I can write an equation or this formula, which is electromotive force equals to current, open bracket, external plus internal. Okay, so let's substitute the numbers. I have E equal 1.636 open bracket 5 plus R. Okay, so let's expand the bracket here. I will have E, I'm sorry, this is E, let me just erase, okay, sorry, okay, so E, electromotive force equals 1.636 multiple 5, I get 8.18 plus 1.636 multiple R, okay, this is 6, okay. So this is the first equation with the two unknown variables, okay? Now I need to look for another equation with the same two variables so I can solve them together, okay? I'll change the color, okay. Now, when the switch is closed, when here it's closed, okay, let me erase these, okay. So, now I have the whole circuit and the external resistance is actually the equivalent of the 5 and 10. As you can see, they are in parallel. So, okay, I'll put here. So, K is closed. Okay? I have the external resistance will be 1 over 5 plus 1 over 10 to the power negative 1. I use my calculator, I will get, well, I did it before, it's 10 over 3 ohm. This is what? This is the external resistance. Okay? Now, I want you to pay attention here. They gave me the current when the switch is closed. It is 1.565, but pay attention. Where is this current? Is it the total current in here? No, it's actually only the reading of the ammeter. So it is only I1. Okay? So this number is only I1. In the formula, if I'm going to apply this formula, okay, the current here, it is the total current. So I cannot substitute 1.565. So, what do I need to do? I need to find the total current, which is, notice here at this junction, okay? There will be I1 going down and I2 going there, to the right, okay? So, I is going to be I1 plus I2, okay? Notice I1, I have it, which is 1.565. I need to find I2, which goes in here. Okay, guys? I need I2. So, I know that I2 is actually the voltage over resistance. What voltage? Voltage in this part, in here, in the 10 ohm. And R is actually the 10 ohm. Okay, I will name it V2 R2. So R2 is the 10 ohm, and here the 5 ohm is R1. Okay, so R2 I have it, but V2 I don't have it. What to do? We need to pay attention that the 10 ohm and 5 ohm connected in parallel, right? So they have the same potential difference. So I say V2, which equals to V1, equals to I1 R1, right? So I1, I have it, where is it? Okay, it's 1.565, okay? Multiple R1 is 5, so this gives me V2, which equals to V1, equals 7.825 volts. Okay, now I substitute this number up here, okay, in order to find I2. So let's find I2. It equals to the V2, it's 7.825 over R2 is 10. So the answer will be 0.7825 ampere. Now I got the I2. Now I go and substitute it in here in order to find the total current. So I equal, I have I1, which is 1.565 plus 0.7825. Okay, you can round if you want, but here I'm using the whole number. Okay, so I equal is going to be 2.34, okay, 75 ampere. Okay, this is the total current when K is closed. Now what to do? Since now I have the total current and the external resistance, I can apply this formula, E equal I external plus internal. So this will give me E equal I, which is 2.35, I will just round it, is going to be 35, okay, open a bracket, the R, we just found it here, the external, it is 10 over 3, right, plus internal, okay, and this will give me E equal, is going to be 7.83, it's going to be 7.83 by rounding, okay, plus 2.35 multiple internal resistance. So this will be the equation 2. Okay, here I will write 2. Okay, so now all I need to do is to solve the equation 1 and equation 2 together in order to get the E and R. Okay, let me erase here to get some space. Okay, if you didn't copy, you can just go back and copy it. Okay, so as you can see here, E in the two equations is the same. The electromotive force of the battery, it's the same. So the first side of equation 1 equal the first side of equation 2. This means I can simply say that the second side equal the second side, which means 8.18 plus 1.636 R equals to 7.83 plus 2.35 R. Again, why I did this? Because in equation 1 the first side is E. In equation 2 the first side is E. It is the electromotive force of the battery in both equations, right? So I wrote the equation right here. So now I need to put the numbers in one side and variables in one side. So I take the 1.6 7.36 to this side, and then bring this 7.83 to this side. So it will be 8.18 minus 7.83 equals 2.35 R minus 1.636 R. By doing the calculation here, I will have 0.355 equals 0.7115, or I can say 71. Okay, I will write the whole thing R. Okay, now if I need the internal resistance, guys, I just divide. So R is going to be 0.353 over the 0.7115. It's going to, okay, I will write everything. Okay, 355 over the 0.7115, which will give me 0.5 ohm. This is the internal resistance. Now I need the electromotive force. I just substitute either in 1 or in 2. Okay, let me go here. I will substitute in that 2. Okay. No, actually I will substitute in the first one, because here in my paper I substituted in the first one. Sorry. Okay, but you will get the same answer, don't worry. So E equal 8.18 plus 1.636 multiple 0.5. Okay, and the answer will be 9 volts. Okay, I hope it's understood. So here I will, no, I want the red. Okay, good. So here, this is the R, which is 0.5 ohm, and this is the E, which is 9 volts. Okay, I hope it's clear. If you have any question, please leave it under the video. Have a great day. Bye bye.